Let's wrap up our 3 introductory examples. Our first one was stopping a car so it wouldn't hit a bike. There, we knew where we started and we generated predictions of how things would behave using our calculus prediction equation. And the rate of change, we just said, let's try a constant like 7 meters per second squared for acceleration, -7. And that wasn't enough. So we said, let's try a constant of -10, and that wasn't enough. But we were just free to try different things and see what the effects were. In the intravenous infusion case, again, we said, let's maybe start with 0 medicine in the body, and we had our prediction equation based on the rate of change. But the rate of change itself, we weren't free to decide on. We had to know a little bit of scientific knowledge about how we were adding a constant amount every hour, but then we lost 16% per hour of whatever was in the body. That's something we can't really change, that 16%. We could change the infusion rate, but we had to determine the rate of change based on a formula rather than just being something that we were trying different values. And then in the population growth, we didn't have to generate data or generate predictions. We already had data. And there we used difference quotients on the data to compute rates of change. And then we also talked about we could do a trend line on to get a formula that describes the data. And chapter 2 will be focused almost entirely on doing rates of change from formulas, but also kind of from graphs. So that's our kind of 3 big things that we saw: generating data or predictions in 2 of them, and 1 of them already having data and dealing with it 2 ways, using difference quotients on the data or starting to use a formula, and then we'll play with that in chapter 2. So now we're ready to talk about what is calculus. One of my kids asked me at the dinner table a few years ago, it's a 7-year-old kid, "Daddy, what is calculus?" And I had to think real fast, what can I say that a 7-year-old can understand? So I came up with calculus is how fast things are changing, and we're going to see that in chapters 2, 3, and 4. And calculus is also about how much things have changed so far, which is more chapters 5 and 6. And we're skipping chapter 1 for now because it's careful to be very precise about theory. We're going to play with the applications first and then come back and be precise about the theory at the end of the course with chapter 1. So this class is also about, this class is about calculus, but getting the ability to do math with modern technology like spreadsheets. I won't be requiring Python or anything, but some people might want to use Python in their final project, for example. It's about having helpful math habits or procedures, checking what's going on, having more than one way to do something. If you were going to drive over a bridge that had been designed by an engineer, you would hope that engineer had not only done the calculations, but done a different way of doing the calculations and made sure it matched the first set so they could be confident in their calculations. And then also, not just doing calculations here, but understanding what is really going on is a big important part of this class too.